Okay, now we're starting section 2.2 where we're going to look at some more graphs. We're not going to concentrate very heavily on this section, not on homework or on the test. Mainly we're going to be looking at the stem and leaf plot and the pie chart are the two graphs that we'll be considering the most. But I'm going to go over these others just so you know that they exist and how they work. Now, when we're graphing quantitative data, we could have used the frequency distribution. But in the frequency distribution, we really lost the actual data values. We knew the frequency of the number of data values within an interval of numbers, but not the actual values. In a stem and leaf plot, we keep the actual data values, but that also means that our original data set needs to be small to moderate at the most. Whereas a frequency distribution, we really could use a very large data set. Now, the way you read a stem and leaf is this 26 is separated into a stem and a leaf. And the leaf is the last digit, and the stem is everything else. So in this 26 becomes a 2, and then the 6. So this 1 stands for the number 21. This 8 stands for the number 28, 30, 36, another 36, there must have been two 36s in the data set, and so forth. Similar to a histogram, because once you draw it, you can see that the length of the row would correspond to a higher bar on a frequency histogram. And we still get to keep our original data values. So suppose we have this set of data. We want to display the data in a stem and leaf. This data is the number of text messages sent last month by these people. Now the entries start at 78 and go to 159. So the stem here would be the 7 and the leaf is the 8, whereas the stem here is 15 and the leaf is the 9. So we have a 78 and we would split the 59 into a 15 and a 9. We're going to list the stems 7, 8, 9, 10, 11, 12, 13, 14, 15 to the left of a vertical line, and then put the leaves to the right of each stem. So for example, here's our 78. This is an unordered stem and leaf. This is not as common. It is much more common to see an ordered stem and leaf where this stands for the 105, 108, 109, 109, 109. You see the leaves are put in order. You can also see from this that if this were going to be a frequency histogram, these would be the longest bars. A dot plot. Dot plot is not very common. I just want you to be aware that it exists. You put a dot down for each of the values. 21, there's the 21. You have two 25s, and there's the 26. If we wanted to do the same data set and use a dot plot, we would put the entries, we would put the vertical count by 5s, and put a dot down where each of these values go. Kind of gives us a picture of where the majority of the data lies. A pie chart. Pie charts are very common, and most of you have seen them all the way back since elementary school. It's a circle that's divided into sectors that represent each category. A pie chart, and in a few minutes I'll be talking about a bar chart, are the two common graphing techniques for qualitative data sets. Each area of the sector is proportional to the frequency. This would be less frequency than that, and this has the most frequency. So let's suppose we look at this example, and we have types of degrees: associate's degrees, bachelor's degrees, master's degrees, first professional degrees, and doctoral degrees. And these are the number in thousands of the degrees that were conferred. We want to put this into a pie chart. Now, I'm going to talk about how you do the pie chart. First, we need to find the relative frequency. So 24% of the degrees conferred were associate's degrees, where 3% were first professional degrees, and 2% were doctoral degrees. We want to take this and split. If you add this up, this will add up to 100%, or 1 as written in the relative frequency. And so we expect about a quarter of the pie to be here, and about a half of the pie to be separated for the bachelor's degrees. To construct a pie chart, you really do need to use a protractor and a compass and figure out angles. We're not going to to do that, but if you wanted to, you would just take 360 degrees times the 24% that the associate degrees were, and you would get 86 degrees, and you could use a compass and a protractor to divide the circle of 360 degrees up into these size sectors. But here's what the pie chart looks like. We can see from this pie chart that the bachelor's degrees are about half of the degrees conferred. Associate's degrees about 25% of the circle. You're just going to be responsible for being able to interpret and read a pie chart, which I'm pretty sure most of you have done before. A Pareto chart is the bar graph. Now, the bar graph is the other one that's used for graphing qualitative or categorical data sets. A bar graph would have these bars. They are not usually connected, and each bar stands for a category. A bar chart could be in, these bars could be in any order, but a Pareto chart is a particular type of bar graph where you start with the bar with most highest frequency, going down to the category with lowest frequency. All right, so suppose we have this example. We're looking at inventory shrinkage, and it's caused by 1, 2, 3, 4, 5 different categories, and let's use a Pareto chart to organize this data. I'm sorry, 4 categories. So employee theft was the highest cause of inventory shrinkage, where vendor fraud was the least. Each of these bars stands for the dollars and billions of loss. Paired data sets. Now, paired data sets are we're going to look at this in much greater detail in Chapter 9 at the end of this term. But right now, I just want to talk to you a little bit about what paired data sets look like. Most of you remember from high school, you had this how to graph points on what's known as the Cartesian coordinate system, whereas this point here has this x value and that y value there, and you plot points on an xy coordinate plane, right? And it's used to show the relationship between 2 quantitative variables. Suppose we look at this example and we have iris data, and we're going to be looking at the length of these petals versus the width of the petal. So for each petal, we're taking 2 measurements, one for its length, one for its width, putting them together, and we plot the points. Plot each of those points. Each of these dots stands for a particular petal that was measured. We do see from this, how to interpret this, that as the petal length is increasing, the petal width also is increasing. It's known as a positive linear, it looks like about a positive linear relationship. Again, I just want you to be aware that this graph exists. We will be looking at this in more detail at the end of the term when we get to Chapter 9. A time series graph is another way to graph paired data, but now we're pairing the data, a time with a quantity. So, for example, the amount of participation measured for every day for 1 month. So this would be day 1, day 2, day 3, day 4, amount of rain, amount of rain, amount of rain on those days. We can use a time series chart to graph. So suppose I have by year the number of subscribers for cellular telephone subscriptions. So this would be my X, or my horizontal scale, and this is my Y value, and I'm going to plot the point 1998, 69.2. Let the horizontal axis represent the years, and we're going to let the vertical axis represent the number of subscribers. So this is a point that you're used to seeing, X, Y, X, Y, X, Y. But notice that we have the years in a time series chart. The difference is the years or the days of the month go in order, right? So we start in 1998, go to 2008, plot the 69.2, the 86.0, and then connect the dots with a line, and we see the trend that cell phone service was increasing, and it looks like maybe over around 2007, it's starting to level off. That's the end of section 2.2. You'll see just a couple homework problems on doing a stem and leaf, and maybe, I think, reading a pie chart. Other than that, The rest of this stuff was just for your information in case you see them later. Right? You can now go to My Math Lab and do homework 2.2.